All right, AP, this is sample exercise 4.083. So talking about neutralization analysis. An environmental chemist analyzed the effluent, and in general that means the stuff going out, effluent, going out. Here it's specifically it's the released waste material from an industrial process known to produce the compounds carbon tetrachloride, which is CCl4, and benzoic acid, which is HC7H5O2, a weak acid that has one acidic hydrogen atom per molecule. So that benzoic acid is going to donate one hydrogen atom per molecule. A sample of this effluent weighing 0.3518 grams was shaken with water, and the resulting aqueous solution required 10.59 milliliters of 0.1546 molar NaOH for neutralization. Calculate the mass percent of HC7H5O2 in the original sample. Go ahead and press pause now, because here comes the solution. Not quite. So in this case, the sample was a mixture containing CCl4 and HC7H5O2. And it was titrated with OH ions, right? They were titrating with NaOH. Clearly, CCl4 is not an acid. It contains no hydrogen atoms. And remember, the definition of acid that we're working with right now is the ability to donate protons, donate hydrogen plus 1 ions. So we can assume that it does not react with the OH ion, the OH minus ions. However, HC7H5O2 is an acid that donates one H plus ion per molecule to react with the OH minus 1 ion as follows. And here is your net ionic equation. Although HC7H5O2 is a weak acid, the OH minus 1 ion is such a strong base that we can assume that each OH minus ion added will react with a HC7H5O2 molecule until all the benzoic acid is consumed. We must first determine the number of moles of OH minus ions required to react with all the benzoic acid. And so we take the volume of the sodium hydroxide. Again, it's given to us in milliliters, so we need to convert that into liters, right? Because any molarity calculation is going to be done in terms of liters. So once we're in liters, we can use our normal molarity calculation to generate moles of OH minus 1. And we get 1.637 times 10 to the negative 3 moles of OH minus 1. This number is also the number of benzoic acid present. The number of grams of the acid is calculated using the molar mass, which is 122.12 grams per mole. And so we take, I mean, it's the same moles. They're 1 and 1 there. The number of moles of OH minus is the same as the number of moles of this benzoic acid. So we start with 1.637 times 10 to the negative 3 moles of the benzoic acid. Use the molar mass of it to convert into grams of the benzoic acid, 0.19999 grams of the benzoic acid. Now the mass percent of the benzoic acid of the original sample, right, we just generated the 0.19999 grams. We divide that by the 0.3518 given to us by the problem, generate a percentage of 56.82%.